you're gonna start with a small piece of copper, so a little piece of copper wire. Whoa! And you're going to chemically change it in 5 different ways, then go through a sixth step where you purify it. And you're eventually going to go back to pure powdered copper. So let's just say if this is 0.3 grams, you'll see if you have 0.3 grams after you chemically change it 5 different ways and then purified it. And you'll find a percent recovery, which is basically percent yield. Obviously, you're not going to do the actual chemical reaction, but some of the things in this lab are very, very concentrated and dangerous. For that reason, we're going to have some very strict safety protocols. So you'll see me with some very, specific safety equipment. It's a neat lab. I like this lab in the fact that the kids are actually getting some exposure to very dangerous chemicals and they have to really be focusing on the safety procedures. So here is the magical piece of copper. Small little piece there, very small. Now notice I have all this safety equipment on, and there's a lot of really nasty chemicals in here. The reason why the chemicals are nasty is because this, if you remember from the activity series of metals, this is very low in activity series of metals. Being low means it's very stable. The acid I need to dissolve it is very concentrated. It's about a 14 molar nitric acid, which is incredibly dangerous. And then from that point on, all the other chemicals are very concentrated too, just because this is such a nasty, such a reactive, non-reactive compound. So this is the copper. We need to first of all get the mass. So that's about 0.22 grams. And I will just put that in my beaker. I'm going to use this beaker the whole time. For all 6 reactions will happen in this one beaker. So I'm going to put in some very concentrated nitric acid with this pipette. I'm going to put about 4.5 mils in, roughly. And I'll just, whoops, I forgot I got to turn on the fume hood. There's going to be some pretty nasty vapors coming out of here. Again, this is going to be both a single replacement and decomposition reaction at the same time. So if you can see it's starting to fizz, starting to turn green, and you can start seeing some of that brown gas coming off. It's kind of starting to get stinky here. The brown gas is actually the same gas you have in air pollution in a lot of cities. A lot of larger cities like Hong Kong and Los Angeles, all the industrial pollutants and car pollutants, they make this orange gas which stays above the city as smog. You'll have smog alerts. If you breathe too much of this in, you'll have some lung problems. It actually is where acid rain comes from too. If you breathe it in, it'll actually react with the water in your lungs and make nitric acid, which obviously burns your lungs. So you can start seeing it reacting. I'll let it sit for a little bit. You can start seeing the brown gas inside. Notice, of course, the green color. It's making copper 2 nitrate. Copper compounds are always blue or green, or typically blue and green. One of our compounds later will be black, actually, copper 2 oxide. Okay, it's all done now. The copper's gone. So we have copper 2 nitrate, which is blue. So we'll take it over now and finish up step 1. Again, put some water, roughly 50 mils. Doesn't make too much difference. Just gonna dilute it out because the acid's so strong. Got some interesting little vapors coming out of there. Okay, so that is actually step 1, all done. So we have our copper 2 nitrate.